Hey class, how you doing? This is Mr. Webb. Just going to give you the last bit of the packet. This is the last 2 pages. Just going to go roughly through some of the classifications, and then how to do the predicting the products with the word problem. So there's kind of a lot you have to do there. So I'll go through a couple of those questions, and then you're off on your own. Again, all this stuff is due when you get back. But if you have questions, make sure you write them down. If you have trouble questions, make sure you circle them so that you can bring them to the forefront when we get back from the break. So enjoy your break and have fun with the challenge of doing with the challenge of doing these problems. And when you come back, you should be ready to go. Okay, as for the second to last page, this is asking you to classify some of these. As you can see, you have multiple reactants and a single product there, so you should know what that one is. Here, it's kind of flipped. You have a single reactant and then multiple products, so you should know what that one is. Here, we have a home wrecker here. So as you go through, you should be able to kind of identify these based on the criteria that we talked about for the 5 types of reactions. Okay, for the last page, we're going to do questions 2 and 3 for examples. So first thing we want to do is identify the type. We have aluminum and then iron 3 oxide. First thing I would do is establish the ions and then make sure we got our proper compound combinations. Okay, so we have aluminum with a +3 charge, iron with a +3 charge, and oxygen with a -2 charge. We have to make sure we do our proper crisscross. So we're going to have aluminum plus Fe2O3 goes to what? This is a single replacement reaction, so the aluminum is going to be replacing the iron. So again, we have a +3 charge going to combine with the oxygen, so that's going to leave us with iron plus aluminum oxide. We want to make sure we go back and get our coefficients ready so we can go ahead and solve that particular problem. Okay, first step we know is to label our elements, so we're going to go ahead and do that. And now we're going to go ahead and count on each side. So we have 1 aluminum, we have 2 iron, 3 oxygen, and on this side we have 2 aluminum, 1 iron, and 3 oxygen. So we have a 1, 2, 3, and a 2, 1, 3. In this particular case, I want to actually address the oxygen first because that's in the combination. The aluminum and the iron should be fairly easy to do because I can put any coefficient I want in there. So let's work on that oxygen. So we have 3 over here, and we have 3 over here, but we're actually straight on the oxygen. So let's look at the iron. We have 2 and then 1. So we'll go ahead and add our 2 in there. That gives us 2 iron. And we have aluminum, which has a 1 and a 2. So we can actually just add a 2 right there. 2. And let's see what we have here. 2, 2, 3, and 2, 2, 3. And looks like we're all done there. Add your little 1 in there. Simple, easy peasy. So you have a 2, 1, 2, 1 combination. Okay, the next one we're going to do is number 3, silver nitrate plus zinc chloride. First thing we want to do is establish our ions. So we have silver, which is a +1. We can go to our chart, look at nitrate, and we have a nitrate. Ooh, can we get that? It's NO3 with a -1 charge. It's kind of tough to see there. We have NO3 -1 charge. Then we have zinc. Zinc is another exception, always +2. And then we have chlorine, which is a -1. So I always recommend getting your ions established first, and then you can crisscross them. If we crisscross them, we know we're going to have AgNO3 plus ZnCl2. We do our crisscross. We know that is a double replacement reaction. So we're going to go ahead and match our ions up. We're going to have AgCl plus our ZnNO3 2, because we have +1, -1, and then a +2 and a -2. So that will complete our, and of course that's a, what kind of reaction? Yes, double replacement. Okay, so what we're going to do now is we're going to go ahead and draw our elements and then begin to count. Okay, so we have our Ag, we have one of those. We have 1 nitrogen, 3 oxygen, 1 zinc, and 2 chlorine over here. And we come into our product side. We have 1 silver, 1 chlorine, 2 nitrogen, 6 oxygen, and 1 zinc. All right, so count. Okay, so the first thing I see that's uneven is the nitrogen, the oxygen, and the chlorine are uneven. I want to go ahead and address that chlorine first. We can do that by just go ahead and putting our 2 in there. It's going to give us 2 chlorine and 2 silver. All right, now we still have some issues with the silver now. So let's go ahead and fix that silver. Put a 2 there, 2 silver. We're also going to get 2 nitrogen and 6 oxygen. Okay, now we see that by doing that one simple move, it looks like everything is pretty much matched up. 2, 2, 6, 1, 2 on both sides. So there you have it. 2, 1, 2, 1. Okay, just to finish up, I just want you to know that you're going to have to do some things with some of these formulas. Hydrogen peroxide is H2O2, and that's going to be breaking down into H2O water plus O2 gas. And when something is catalyzed, it just means that, you know, it's speeding up the process. So there's no change to the equation there. And I think there's one more. Yes, there is. The sodium and hydrogen combine to make a compound NaH, sodium hydride. So just keep a lookout for that. You're going to combine the sodium and the hydrogen to make NaH, which is sodium hydride. So those are the ones that may be a little tricky that you should now be able to do. Go ahead and finish your packet and enjoy the rest of your break.